All right, here's the pre-exposure video for 8.4. And I've already mentioned a number of times now that the geometric series, and I just sent a video on the telescoping series, are unusual in that you can find an explicit formula to define the series. Often you can't. So how do you tell whether a series converges, or really how it converges, without having that information, that explicit formula? So there's two new tests that you're going to learn in 8.4, and they're tests for convergence. And actually one of them's a test for divergence, but we'll get into that. Two new tests for for convergence, and one is called the divergence test, and the other is the integral test. And just as its name suggests, we're going to be doing some work with integrals. Specifically, you're going to be working with improper integrals. So, probably a good idea if you struggled on the last part of Chapter 7, you should go back and make sure that, and I had videos out there for you on some improper integrals. So, that's really where we're heading with 8.4. So let me just lay out a few things for you, and we'll start by looking at a series that is pretty common in nature, and it's called the harmonic series. Sounds musical, right? This is actually one of my favorite series, and I think probably because of the name. You know what? I'm going to take it from 1, because that's undefined at 0. Not a wise thing. Okay, 1 over k. So this is called the harmonic series, and it looks like this if you expand it. All right. I guess why it's one of my favorites is that its behavior kind of fools you. So the question that you have with a series like this is, does it converge? Does this converge? $1,000,000 question that you ask for every series that you come across. Graphically, it looks like it tapers off, but you can't say for sure whether it converges. So if you look at the graph of it, right, when you graph any series, n is on the x-axis, and then the value of the series is on the y-axis, the AK value. So it looks something, starts at 1, right? So, it looks something like this. And it looks like it's got some sort of horizontal asymptote, but you can't say for sure. Then if you look at the table of values, and I'll show you this information when we get to class, but when you look at the table of values, the the term out to 10 to the 40 has a value that's approximately 92.68. So if you were to put this thing in your calculator, you're thinking, oh my gosh, it's got to converge. We need help, right? Because we can't say for sure whether it does or not. We need help. And that's what enters in some of one of our 2 new tests that we're going to talk about in class on Monday. All right. I want to end with just a couple properties of convergent series, so that when I get into the specific tests, I'm not going to get into the specific tests in the pre-exposure videos. I just want you to get an idea of where I'm going with this. But I do want to go through some properties of convergent series that you should know. And they're common sense things that you already sort of know from the limit laws, but properties of convergence series. And all right, we're going to look at the sum of the AKs for AK greater than 0. I don't know if you've noticed, but at this point in Chapter 8, we have only been working with positive series, right? All the AKs were greater than 0. There's a special section on alternating series, but at this point we're only looking at AKs greater than 0. So one of the first properties is that if you multiply each and every AK by a constant, then you can just pull it out of the series and evaluate the series. If the series evaluates to A, then you multiply the A by the constant, okay? And it falls out for reasons much like the limit laws. If you've got two series, right, a series of the AK and it converges to A, and you have a second series, BKs, and it converges to the B's, to B rather, then if I add these two series or subtract them, right, so either adding them or subtracting them, I'm going to be able to add or subtract their convergence points. And the third, which is really important, and hopefully it makes sense, that whether a series converges does not depend on a finite number of terms added or removed. So what I'm saying is, I'll show you in a minute, but let me write it first. Whether a series converges does not depend on just a few terms. Does not depend on a finite number of terms added or removed. So what that boils down to is that I can play around with indices, and that's going to become important a little bit later on in the chapter. So whether I get a series that starts at 1, goes to infinity, right? If that series converges, then the series starting at some other point M going to infinity is also going to converge. So actually they're going to both either converge or diverge together. So adding or subtracting a few terms when you're talking about an infinite series isn't going to determine or change the outcome of convergence or divergence. However, it will, this is important, it will change the value of a convergent series. Obviously, right? Because you're going to be taking out a few terms or removing a few terms, or taking out a few terms or adding a few terms. So it's absolutely going to change the value of a convergent function, but not whether it converges or diverges. All right, so I think I'm going to wrap up the pre-exposure there. I don't want to go on too much longer. Hope it helps. I hope these things are helping. We're trying.